Take a look at some of these questions on the Unit 1 review. This first one, it says, last year, Pinwheel Industries introduced a new model calculator. It costs $2,000 to develop the calculator and $20 to manufacture each one. Complete the table of values showing the total cost C of producing N calculators. Okay, so no matter what, they are going to pay $2,000 and then plus $20 per calculator. So $20 if they manufacture 100 calculators, it's going to be $4,000. And we would write that in this first blank. Okay, we're going to continue in this manner to fill in the rest of the table. Okay, so I'll just do one more. 2,000 plus 20 times 500. Okay, and altogether we would get $12,000, and we would put that in this next blank. Okay, so complete the rest of the table. In part B, we want to write an equation that expresses C in terms of N. And so we really already have our formula if you write out your work for evaluating these expressions in part A. So the cost is equal to 2,000, the constant, plus 20 times the number of calculators manufactured, which is N. You could write this in function notation because it is a function, and you could write, instead of C, write it as C of N. Okay, next we want to graph the equation. So I'm going to just make a quick sketch, and I know which axis is which. Okay, so the horizontal is the N and the vertical is C. And using a couple of points from our table, we can at least get the direction of how the line should be formed. The y-intercept from the equation is kind of an easy point to graph, which is at 2,000. Okay, and then just pick another point that's in your table, one that's kind of clear, a little bit clearer to graph. And so 500, 12,000, so that would look like somewhere in this area. If you found all of these others, it would be 1,500, 32,000. And so I would want to make sure, kind of do a little verification, that the line slants and would pass through those points that are in my table and looks something like this. Okay, part D, what is the cost of producing 1,000 calculators? So we can use our formula. C is equal to 2,000 plus 20 and substitute 1,000. For N, and we get 22,000, and that's in dollars. And it says illustrate the point on the graph, and so if I go over to 1,000 on the N axis and go up to the graph, you can see how this C value should be around 22,000. And lastly, how many calculators can be produced for $10,000? This is a C value. Okay, so we can set C equal to 10,000 in our formula and solve this equation for N. Okay, so by hand, I would just subtract 2,000 from each side. Okay, that gives me 8,000 is equal to 20N, and then divide both sides by 20. So altogether I get N equals 400, and that's a number of calculators. So 400 calculators. We can verify this answer on our graph. If I go back up, Okay, and I'm trying to find when the cost is 10,000, so that's somewhere right here in this area, and then kind of drop down to the n-axis, and that does look like it's about at 400. Okay, number 2, the world's copper reserves were 950 million tons in 2004. The total annual consumption was 16.8 million tons. And so we are assuming that the copper consumption continues at the same level, and write an equation for the remaining copper reserves R as a function of time t, which is in years since 2004. So R of t is my function. The reserves started at 950 million, so 950 minus. And because it's decreasing, that's why I'm putting a minus, and total annual consumption is 16.8 million tons. That's per year, so total annual. So per year, it happens again and again, and so that's what's going to have the variable next to it. So 16.8 t. Okay, in part B, we want to find the intercepts and then graph the equation. So the t-intercept is when R is 0. Okay, so if R is 0, I'm just going to say 0 equals 950 minus 16.8t, and we'll solve this equation for t. Okay, so I would move one of these terms to the other side, so I'm going to add 16.8t, okay, to each side, and then I have this equation, 16.8t equals 950, and we'll divide both sides by 16.8. Okay, and so altogether 950 divided by 16.8 is about 56.5. I'm going to use these approximately equal to this symbol because I'm rounding. Okay, well, the other thing we need is the R-intercept, which occurs when t is 0. Okay, so this should be easier to find. We're really finding R of 0 and plugging 0 for t. And so that's 950 minus 16.8 times 0, and that's just 950. Okay, we then have 2 points, and we know that the line should pass through both of them. And so I'll just kind of make a quick sketch. Okay, and we'll put one point at 0, 950, which is very close to 1,000. And then the other at 56.5, 0. So here's 50, and here's 60, so just a little bit past the middle. And then connect those 2 points with a straight line. And in the last part of the question, we're asked to kind of explain the significance of these intercepts. And so I think it helps if you do write them out as ordered pairs and label. Okay, and so the first one in the year 0, so when t equals 0, but that's really the year 2004. The reserves were 950 million tons, okay, but after 56.5 years, and now that's after 2004, so 2004 plus 56.5 is somewhere in the middle of the year 2060. So in 2060, the reserves will have been depleted. You see that the reserves are 0, okay, if the consumption continues at the same rate. Okay, and number 3, the owner of a movie theater needs to bring in $1,000 at each screening in order to stay in business. He sells adult tickets for $5 and children's tickets for $2 each. Write an equation that relates the number of adult tickets A he must sell and the number of children tickets C. Okay, so this is equation is going to look something like this. $5 for each adult ticket. So 5A is the amount of revenue that he would bring in from selling adult tickets. Okay, plus 2C is the amount of revenue from selling children's tickets is equal to altogether the total revenue he would need is $1,000, and so equals 1,000. Part B, find the intercepts and graph the equation by hand. So we have 2 intercepts. The A intercept occurs when C is 0. And so you can just kind of cover up this second term and you get 5A equals 1,000 and divide both sides by 5. So A is 200. And then the C intercept occurs when A is 0. Okay, and so cover up the A term and you get 2C equals 1,000, and therefore C, if you divide both sides by 2, is 500. Okay, and then we want to make a quick skip. Okay, so the A intercept was 200. I'm just going to make sure my line passes through this point, and the C intercept was 500, and then connect those 2 points with a straight line. And then we're also asked to explain, or let's see, in part C, we're asked to find if the owner sells 120 adult tickets, how many children's tickets must he sell? Okay, so we're given that A is 120, and so using this equation, 5A plus 2C equals 1,000, we're going to just substitute 120 for A. Okay, and just solve this equation for C. And you should get that C is 200. Okay, and one other thing, in part D, it asks for the significance of the intercepts. So we go back to part B where we found the intercepts, and it's often nice to write those intercepts as ordered pairs. And so 0, 500, and the other one was 200, 0. And then write the ordered pairs, label them with the correct variables. So that would be an A and a C, okay, for each of them. And so if this theater owner sells 500 children's tickets, he would need to sell no adult tickets, okay, because he would have met his revenue goals. And then if he sells 200 adults, he doesn't have to sell any children's tickets.